It's the greatest quest of all time. Astronomers are searching the heavens for a new world. Not just any planet, but a world like our own, teeming with life. Radical technologies enable scientists to search deeper. If they succeed, astronomers will have found the ultimate prize. A discovery so profound, it will change the destiny of mankind. On board this rocket is the start of a magnificent quest. It's an international mission to answer once and for all the question, is there anyone else out there? The plan is to search the galaxy for rocky worlds that can support life.
The ultimate goal is to find a planet like our own Earth.
In 2006, France takes a first step towards that goal with the mission called Corot.
Corot is pioneering. It's the first space telescope to spend significant amounts of time planet hunting.
The French plan to launch Corot from Russia's Baikonur Cosmodrome in Kazakhstan. Rockets have flown from here for over 50 years. Back in Paris, Corot team member François Frisson is worried.
The launch is scheduled for the end of December. Temperatures are extremely cold, around -20 degrees Celsius.
Freezing temperatures make rocket parts brittle, a fact learned the hard way by NASA.
We were all raised with the memory of the Challenger accident. Each component was carefully studied on the ground. We were acutely aware of the risk of failure in flight.
The rocket releases Corot 900 kilometers above the Earth. With the challenges of the launch over, Corot still faces a daunting task: to find the next Earth in a sky full of stars. Over a decade earlier, a different spacecraft revealed just how difficult the goal is. In 1990, Voyager 1 created a portrait of our entire solar system. The star dominating this photo is our Sun. It is roughly 1 million times bigger and some 10 billion times brighter than our planet. We are lost in its glare. Adjust the brightness of the Sun, and this tiny blue smudge appears. Earth, as seen from the edge of our solar system, 6 billion kilometers away. Finding our tiny planet in the burning glare of the Sun is like trying to read a car number plate with its headlights aimed at you. But Corot introduces a powerful piece of technology. It has 4 CCD detectors, components which convert light into a digital signal. 2 of the 4 are dedicated to finding planets by observing transits.
A transit occurs when an object passes in front of one of the many stars being observed by Corot, thus dimming the light from the star.
But other things can mimic a transit, like sunspots. They cause a star's brightness to dip, but they're erratic and temporary. If a star dims at regular intervals, the Corot team will know they've found a planet. Expectations are high. With a vantage point above Earth, Corot has an unsurpassed view, but that view comes with risk. Corot's orbital speed is almost 27,000 kilometers per hour. Contact with any debris could be lethal. That puts Corot in a dangerous game of orbital roulette, but a sudden impact could end the mission at any time. For now, Corot is safe, and France has the skies all to itself. But the race to be first to find the next Earth is about to heat up. In 2009, at the Kennedy Space Center in Florida, a Delta II rocket rose out to pad 17B. Teams of engineers adjust and readjust every working part. To launch its payload, the rocket will burn nearly 200,000 liters of fuel in less than 5 minutes and will race from 0 to Mach 1 in 35 seconds. On board is the culmination of a scientific revolution some 20 years in the making, the Kepler Space Telescope, the latest achievement of American spaceflight designed for one purpose: finding the next Earth. But the team is on edge. Just 2 weeks earlier, something goes wrong at a routine launch.
In all stations, this is the NLM on countdown. It appears we've had a contingency with the OCO mission. Please enact the mission mishap preparedness and contingency plan.
The nose cone shielding the satellite fails to come off. The mission is a total loss. The nose cone around Kepler is a similar design. The pre-flight inspection reveals no problems, but nerves are raw.
We're putting this instrument that we've spent a large portion of our careers thinking about designing, planning, building, fine-tuning, engineering, all of that. And now you're taking that spacecraft and you're putting it on a tower of explosives and sending it out into space.
22 seconds. Storage tanks in. Open. Open. Rapid load. Close. 9. 10 feet. I do have it. 13 seconds. 17B launching their razor blade. 2, 1, and liftoff. Tanker pressures are building. Pressure's looking good. Increasing at this time. Well, the solid motors are building tanker pressure.
Now comes the moment of truth. The nose cone must break away.
And mark.
For the Kepler team and the mission to be the first to find the next Earth, the time has come for their new space telescope. But it might be too late. There is news from Paris. It appears Corot has hit the jackpot. About 500 light years away, in the constellation of Monoceros, a world made of the same rocky materials as Earth has been found. The new planet is designated Corot 7b, and for astronomers, It may be the first of a new kind of world.
We call these planets super Earths. You can think of them as big, hefty versions of our own planet, with masses that range from maybe twice as big as the Earth up to about 10 times the mass of our Earth.
But the similarities end there. Earth takes 365 days to orbit the Sun, quite unlike Corot 7b.
A year on Corot 7b lasts only 20 hours, so the conditions must be absolutely different from what we know here on Earth.
Which means Corot 7b is close to its star. Too close. Surface temperatures average 2,000 degrees Celsius. Volcanoes could rule a tortured landscape. Their plumes cross the sky, raining pumice and hot lava. Giant chasms rip through the ground. Corot 7b is the first rocky planet ever discovered around another star. But it's a supersized monster, a vision of hell, and not the next Earth. Could there be another way to search the galaxy? Astronomers like John Johnson think so. His quest begins in an unexpected place, inside a rainbow.
This is the spectrum of a star just like our sun. And what we're seeing is the light from that star split up into its constituent colors.
But the rainbow is not perfect. Stretch it wide enough and gaps appear. Johnson hunts for planets by tracking the subtle shifting of these gaps.
The locations of these lines does subtly change over time if the star is moving, and that's because the light from the star will be Doppler shifted as it moves towards us and then away from us.
We live with Doppler shifts every day here on Earth.
When an ambulance goes by, it first sounds very high-pitched, wee, 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 and as it passes, goes away, it's woo, 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 as it goes away. And so we're seeing the same thing from the light emitted from the star. It gets compressed and higher-pitched, and then stretched and lower-pitched as it's being moved towards and away from us.
But what could cause a giant star to move?
And what would cause a star to do that is an orbiting planet. The planet tugs on the star, and the planet will actually cause the star to accelerate periodically.
But the tiny gaps in the spectrum can also reveal the chemical makeup of a star, and they can do the same for a planet. This group of black lines comes from our own atmosphere. It's the chemical signature of Earth itself, a planet filled with life. Johnson dreams that one day he will be the first to find this sequence around another star. Astronomers from the Lick Observatory are tracking what they hope will bring them that Nobel Prize. The wobbles of a star some 20 light years away in the constellation of Libra. Like John Johnson, astronomer Steve Vogt uses the rainbow spectrum to see the wobbles. The star is called Gliese 581, and hidden in its glare, Vogt has discovered what he hopes is a planet filled with life. He refers to it by another name, Zarmina's World.
I thought, this is a really beautiful planet, it needs a beautiful name, and I named it after my wife, Zarmina. It's totally unofficial, though. It will be known as Gliese 581g in the astronomical literature, but I call it Zarmina's World.
Gliese 581g could be one of several planets orbiting its star, and because of its size, it could be a super-Earth, like Corot 7b.
Well, it's a good place to be a realtor because it has about 2 to 4 times the surface area of our planet. You'd feel a little heavy. You'd be maybe 1.5 to 2 times heavier, so you'd feel a little tired, but you could walk around.
Zarmina's World has something in common with our moon. Just as one side of the moon always faces Earth, one side of Zarmina's world always faces its sun.
Depending on where you were, the sun would be fixed in the sky. So if you were on the daylight side, it would always be daylight. If you were on the nighttime side, it would be perpetual nighttime.
The land on the day side is a vast forbidden desert, roasted by killer solar rays. On the opposite side of the globe is a land of perpetual darkness, a realm of frozen wastes, dominated by a massive glacial sheet. Yet hidden among the edges is a narrow transitional zone spanning the globe from pole to pole, an oasis locked between two brutal wastelands where life could exist.
I would be pretty assured that some form of life would have taken a foothold there.
High on a hill in La Silla, Chile, the same team of Swiss astronomers who were able to confirm 4 other planets orbiting the star Gliese 581 is baffled. No matter how hard they try, they cannot find Zarmina's world. The team is left with only one conclusion: Zarmina's world does not exist. Perhaps this elusive planet, with its promise of life, may reveal itself again sometime in the future. Meanwhile, trailing in Earth's wake by millions of kilometers, the Kepler Space Telescope is still in the race as it searches the cosmos from deep space. Kepler's array of 42 CCDs is aimed at a single patch of sky containing 4 million stars, and it has only one purpose: finding the next Earth. But there's a glitch.
When we launched the spacecraft, I think we all knew in the back of our minds that there was some risk associated with this. The environment out in space is not completely benign. There are micrometeorites, there's radiation, there's this big luminous sun there that could do damage to our electronics. And here, just a few weeks after launch, we have a safe mode.
A safe mode happens when the spacecraft thinks something is wrong.
An alarm gets tripped. It's a series of instructions that we give to our computers that tell the system to shut down completely. When you turn off the electronics, the temperature of the spacecraft and all of those components inside changes. They begin to actually cool down because the electronics, when they're on, it keeps it warm.
Temperatures in space can reach a lethal minus 273 degrees Celsius.
That made us all very nervous. We wanted to very quickly assess exactly what it was that happened, why it happened, was it something really potentially dangerous, and if it was, did it damage anything on board? If the spacecraft were to die, we would not be able to find the true Earth analog, and years of our lives would then be for naught.
Hours pass while the team searches for the cause of the safe mode.
So we hold our breaths, waiting for that assessment.
At last, the team makes its report.
Yes, everything was okay. It was not slewing over towards the sun. We didn't get sunlight streaming down into our telescope. Everything checks out. Everything's okay. Let's go ahead and power back up.
As the spacecraft reboots, mission scientists lament the true cost of the safe mode: the loss of precious data.
The whole name of the game here is to find an event that lasts 12 hours in a sequence of data that's 3.5 years long. So it's heartbreaking when you've got a safe mode event and you know that you're no longer taking data. We're all wondering which Earth-like planet out there is currently passing right in front of its parent star during that time that we're not collecting data.
The longer the safe mode, the more likely a planet will slip by. But even with the interruption, Kepler has seen a huge amount. When the Kepler team releases the results of their harvest, it's a giant leap forward in the race to find the next Earth. Over 1,200 possible planets. If they can all be confirmed, Kepler will single-handedly triple the number of known worlds. Most are massive gas giants, some even bigger than Jupiter. But at least one is about the size of our own Earth.
It just popped right out at us. And so we knew at that moment right away that we were going to be able to see the signal of a really Earth-sized world.
It's a planet that will come to be known as Kepler 10b. It's the smallest world ever discovered outside our solar system, and it takes the Kepler team one step closer to finding the next Earth. Kepler 10b is not only rocky, it's roughly the same size as our home planet. But does Kepler 10b really exist? Does this mountain of data add up to a planet? Or could it be another mirage, like Zarmina's world? Natalie must confirm the finding. She relies on one of the most powerful telescopes ever built. It stands at 4,000 meters on the shoulders of a dormant volcano. Because it's so difficult to access, Natalie, like most astronomers, works remotely with this marvel of technology. Today, she has come to the cold summit of Mauna Kea in Hawaii to see the Keck telescope in person for the first time.
Oh my God.
Ron Lobb has worked at the observatory for years.
Oh my God. Wow.
Welcome, Natalie,
Hi.
to the Keck telescope and the awe-inspiring 10-meter primary mirror.
Each of Keck's twin telescopes consists of a giant 10-meter mirror. These mirrors are made of 36 hexagonal segments that weigh almost half a ton apiece. Small motors in the back of every segment keep them working together as a single giant mirror. Keck also combines this telescope with a high-powered laser. The laser tracks and removes the distortions in the air that cause the stars to twinkle. This makes Keck one of the most sought-after telescopes in the world, and one of the best places on Earth to confirm a discovery.
We have to compete with other astronomers for time on this telescope. The whole Kepler project only gets 20 nights a year. So we have to be very choosy about the planet candidates that we pick to confirm here.
Natalie shares her data with Ron. The existence of Kepler 10b is confirmed.
Every single dot is marking a transit. There's just a forest of transits here in this data. So these are Kepler 10b. They're so close together because the orbital period is so short.
This means Kepler 10b is extremely close to its sun and blasted by the solar heat.
We look at these charts and graphs and we tend to forget about the reality of that planet.
Could life as we know it exist on Kepler 10b? Metallica decides to find out. She joins planetarium director Sean Loch at the Kilauea lava fields on the Big Island of Hawaii.
You can start to see, of course, this really black
Look how
area.
dark it is.
This flow is only a few years old, which is pretty amazing.
This landscape is similar to the kind of terrain Natalie thinks is on Kepler 10b.
I can see these sparkly flecks in the air here from the sunlight reflecting off of it. I bet that's pretty dangerous to breathe in, huh? It looks like a rope or like licorice, you know, it's twisted. I'm scared to know what's underneath here. Jeez.
Like Zarmina's world, Kepler 10b keeps the same face towards its sun. One side trapped in everlasting day, the other side in eternal night. This lava field is what the night side might look like.
Oh my God, it's getting so hot.
Yeah, isn't this incredible? And you can see the flowing up there through there,
it's
and up from top.
Flowing.
Yep.
Oh my gosh, it's so hot. There's our sample of Kepler 10b. Already hard.
If you can take it home in your Ziploc
I
bag.
can't. It's not going to cool off quick enough, huh?
I don't think so.
I think it'll burn a hole in my pocket.
Yeah.
Okay, ready? Let's see if we can cool this rock. Something we don't have on Kepler 10b, right?
Right. A little bit of water.
Conditions on the night side are extreme and inhospitable for life to exist here as we know it. But nothing on Earth compares to what's on the day side. Passing from night to day, temperatures reach over 1,300 degrees Celsius, hotter than a blast furnace. The hemisphere is dominated by an ocean of molten lava. Giant chunks of iron-rich rock could be floating near the shore. streams of lava tumble over numerous lava falls. Kepler 10b may be a rocky planet nearly the same size as Earth, but it is a world hostile to life, and yet thousands more planets are waiting to be explored in the search for the next Earth. Can astronomers actually find it? Or are we all alone in the universe? Mars, a world that has tantalized humanity with visions of alien civilizations. But this is not Mars. It's Death Valley. Astronomers Sarah Seeger and Oded Aronson have come here on a search for life.
It's not too hard to imagine that we're actually not here on Mars Hill in Death Valley, but actually in a very similar place on Mars.
Because of its similarity to Mars, NASA uses it as a testing ground.
So a couple of decades ago, there were a group of geologists that were out here looking for sites that would help them calibrate some of the instruments that they were hoping to send someday to Mars. And they said, wow, this looks just like the Viking landing site. And indeed, eventually they came up with a description of the kind of instruments that they would want to send to Mars.
But this isn't the only alien landscape in Death Valley. What conditions are necessary for life?
What really matters is the temperature at the planet's surface.
Life as we know it exists only in a narrow range of temperatures, determined by a planet's distance from its star.
This fire represents a star like our sun. It's so excruciatingly hot near the star. It's hot enough to not just melt lead, but even to melt rock.
A planet can also be too far from its star.
Far from the star, it is extremely cold, way too cold for life as we know it.
But what if a planet is in a place where temperatures are just right? A term scientists have taken from the children's story Goldilocks and the Three Bears.
Here in the Goldilocks zone, the temperature is not too cold, not too hot, but just right for surface liquid water.
In the end, it's all about water. Finding life and the next Earth depends on it. Our planet has some 1.39 billion cubic kilometers of water, and almost everywhere you look, there is life. But here in Death Valley, life can be difficult to find. And in a place as hot and dry as this, it comes as no surprise.
The hottest temperatures ever in North America were recorded here at 134 Fahrenheit. This is one of the most inhospitable places on Earth. It is so hot here, even in winter, that it's almost unbearable. What's weird is that it looks like winter back home. It looks like there's snow on the ground. This is actually an immense plain with water that used to be here that is now evaporated. And what's really weird is it's not snow, it's salt.
Is there any water in Death Valley? One of the most arid places on Earth. Sometimes, when it rains. The rain falls hard here, sweeping away almost everything in its path. And all that water disappears in a flash.
Was this place filled with a lot of water at some point?
It wasn't a lot of water, but every so often you get a rain storm that floods the plains around here, and then the floodwaters stream through these valleys, and then they form these muds that you see here that flake pretty easily.
It's quite a lot, actually. How long do you think the water stays here for?
Oh, probably a few days.
Hardly enough time for life to flourish. Can anything survive year-round in an extreme environment like this?
So we're just about to cross sea level here, and now we're descending down below sea level. There's not many spots on the Earth that are deep below sea level. This is one of the deepest. Off on the horizon you can see some of the salt flats. So Death Valley is basically a big bathtub that has no drain.
And in this giant bathtub, there's a surprise. Oded and Sarah are not sure what they'll find.
It's very salty.
Yeah, I can see all the salts along the bank.
In fact, it's so salty that most life forms that we know can't live here. But there's some life that has adapted to these extreme conditions.
Like what?
And if you look at some of these algal mats, some of these, let's see if we can find a piece. So there's algae that grow here. These are algae that really like salt. They're called halobacteria.
The water in this creek does not come from rain. Instead, it seeps from beneath the ground, like it could on Mars or on other rocky planets.
It's about 2.5%.
Let me check.
You can take a look.
Yes, it is, almost exactly. So what does that tell us about how salty the water actually is?
So ocean water can be up to a couple of percent in its salt content. At about 20%, salt just precipitates out and crystallizes. So this is well below saturation.
One tiny fish has not only adapted to a hellish environment, it's managed to outwit extinction. The Death Valley pupfish is the last surviving species from an ancient lakebed that dried up here during the Ice Age, leaving behind this harsh desert in its wake. If life can survive here, Sarah believes it can take hold anywhere. All it takes is liquid water, no matter how little.
Everywhere you look, there's life. In salty environments and dry environments, in acidic environments, life is in almost every single square kilometer of Earth, wherever there is water. One thing is for sure, that with exoplanets, anything is possible under the laws of physics and chemistry. So if there's salt here in this river, if there's salt here in this creek and life is here, you can bet that there's an exoplanet somewhere where all the watersheds are this salty and where there is abundant life.
But proving water exists on a planet trillions of kilometers away is a daunting challenge, far beyond the ability of Keck, Corot, and even Kepler. New tools, a new telescope, and an entirely new way of seeing the cosmos are all needed in the race to be the first to find the next Earth. Mostly unnoticed, in secure, clean rooms, the future is under construction.
As you can tell, it's a little bit noisy in here, and that's because this room needs to be kept very, very clean.
Teresa Segura is a lead scientist on the next generation in space exploration, the James Webb Space Telescope. Teams of scientists are hard at work on a marvel of engineering that will soon scour the universe for signs of life. James Webb will orbit the Sun in tandem with our planet from a perch 1.5 million kilometers away. The telescope's precision optical system only works in the extreme cold of space, where it's some 200 degrees below 0 Celsius. Solar heat can destroy Webb's delicate electronics. Five layers of specially designed Kapton blankets work in concert to create the highest sun protection factor in the galaxy.
The sun shield is protecting the Webb telescope from the sun, just as you put on sunscreen, except the equivalent of the sun shield is 1 million SPF, not the 50 that you're used to.
Unlike most other telescopes, Webb will search for the next Earth in an invisible part of the spectrum, the infrared. That's because viewing the universe in the infrared allows a telescope to peer through dusty clouds and see further and more clearly into deep space than in the visible range.
The Webb telescope is the largest infrared telescope ever built, and it operates in the infrared because it's looking for very faint objects. You can think of infrared as heat. You can feel heat, but you can't actually see it with your eyes. Another good example is night vision goggles. You can't see at night, but when you put the goggles on, you can see things around you because the goggles function in the infrared.
But the Webb telescope is like an extreme version of night vision goggles.
Webb's ability to see faint light is so good that it would be able to see a night light on the moon from a spot on the Earth.
It's the most powerful infrared telescope ever designed. But transporting this collage of mirrors, Kapton, and electronics into space presents an enormous challenge.
It is actually wider than a two-story building is tall, and because of that does not fit in any current rockets. And so we had to segment it, and that is make it into 18 individual segments so that we could fold it up, sort of like origami, and fit it into the rocket. So we could consider it the origami telescope.
Once it's unfolded, the telescope will set its sights on finding water and the chemistry of life by analyzing the atmosphere of alien worlds.
James Webb can detect the key ingredients for life, that being carbon dioxide, carbon monoxide, methane, and water.
All in the hope of answering the question, are we alone? Perhaps leading to the ultimate prize.
Finding life on any planet besides the Earth would just be the discovery of a lifetime.
And that discovery will owe a lot to all that has come before. 2008, the venerable Hubble Space Telescope makes history. These are only a handful of pixels, but together they are the first direct image of a planet captured around another star. The planet is 25 light-years away in the southern constellation of Pisces Australis and is called Fomalhaut b. For astronomers, the day is coming when this handful of pixels is another Earth.
We're developing the technology right now to one day be able to take a picture of a planet.
And when they do, it will change our lives forever. It's one of the most famous photographs in the world, the Earth as seen for the first time from space by the crew of Apollo 8.
I think that the first images of Earth from the Apollo missions changed the way that people thought of Earth. And when we find pale blue dots, other Earths far away, it'll just completely change the way that we see ourselves.
It's very different to actually know, to be able to look up in the sky, point to a star, and say, I know that there's living creatures right there, right there.
Mankind is on the verge of the greatest revelation in history. There may come a time when we look out at the sky and know that we are looking at another planet far away where there is life. An alien Earth with its own civilization looking right back at us.